Hi, welcome to another edition of Design Spark Ask the Expert. Today we're going to be talking about pneumatics with Festo, and I have Roland Volk from Festo. Hi, Roland. Do you like to introduce yourself to Design Spark?
Yes, hi Greg. Nice to meet you. And my name is Roland Volk. I'm the expert for energy efficiency here in Festo in Germany headquarters, working for Festo since more than 20 years and more than 12 years now in the topic energy efficiency.
Yeah. So one of the things when we talk about pneumatic systems, obviously they can be very large, they can be quite small, but why is it important to have a holistic overview of what a pneumatic system is?
Yeah, the compressed air system consists of several components. This is the generation, so the compressors. Then we have the central preparation, the drivers and the filters, the distribution, the pipings, the hoses to the machines, and finally the application, so the machines and the tools. And if one component is changed to possibly saving energy, this can have negative consequences and perhaps even cause higher energy consumption at another component. Therefore,
Yeah.
the compressed air system should be considered as a whole system. An example, the compressor supplier makes an analysis and select a new compressor according to this calculation. In the meantime, however, leakages are searched in the production and will be also repaired. So thus the consumption is reduced and the compressor is much too large, and then it's not operating efficiently.
Great. Okay, so it's also mentioned, that a compressed air system can be sometimes inefficient, and costs for compressed air can be quite high. So what is it we're actually looking at in reality in the terms of cost per cubic meter?
Yeah, the inefficient system, this is for old-fashioned compressor system. This is certainly true. The energy flow diagram on the left side of the picture, as you can see in the background, applies to here. The statement that the compressor system has degree of efficiency of only 70% may be true in the past, but today compressor systems are much more efficient and can achieve a degree of efficiency around about 20 to 30% in practice.
Right.
If the waste heat from the compressors is also used to support the heating of the building or produce hot water for locker rooms, the efficiency of the system increases up to 60% and more.
Okay. In terms of when we're looking at a compressed air system, then whereabouts in the system can those saving potentials be made? Is there some areas that you need to focus on more than others that will give you a greater return in terms of savings?
Yeah, sure. But let's talk first about the cost for compressed air. This is different between country to country, between customer to customer, depends mostly on the energy prices. And the compressed air index, this is an index for a compressor system. This is around about between 90 and 120 watt hours to compress 1 cubic meter of air to 6 bar. And the actual energy prices here in Germany, it's around about 25 to 30 euro cent per kilowatt hour. And if you calculate with a compressed air index of 105 watt, 110 watt hours, then we have at the moment 3.5 euro cent for a normal cubic meters compressed to 6 bar.
Right.
And the costs for compressed air, they are divided. 75 to 80% is energy cost, and then we have 25% of fixed cost. This means the investment, the maintenance, all the maintenance parts, and so on. These are the other 25%.
Okay, that's interesting because I think we might come on to some of the fixed costs. It could be, component selection, maybe later on in the discussion. Yeah.
Yeah. And the saving potential, what you ask, I think we have now the slide 4 in the background. We have the generation. These are the compressors, and there we have 2 technologies. Normally, it's load-unload compressors, or we have speed-controlled machines. And it makes definitely no sense only to use only load-unload compressors and only speed-controlled compressors. The best is a mix between. And if you have then an overhead control system, then the system can decide which compressor fits best to the actual consumption and switch on this compressor immediately or switch it off.
Okay, so what you're showing me there, obviously, I can see that the biggest potential is at the machine/application.
Mm.
So, if you were to give me some kind of tips behind where do you find those low-hanging fruits? What are the areas within that I need to specifically look at?
Low-hanging fruits in the machines are, especially for existing machines, they are leakages. Some
Right.
broken hoses or loosened connectors, defective valves, and so on. Then we have blowing nozzles to transport, to clean, to dry the parts. Vacuum generators running the whole day if vacuum is needed or not. Then oversized pneumatic actuators.
Hmm.
Sometimes you see really, really big actuators with a diameter of 100 millimeter to move a part which have a weight of 500 grams. Normally, you can use their cylinder with 12 millimeters diameter and save so a lot of compressed air.
Yeah.
Also, long hoses between valves and cylinders is we call it dead volume because we have every time to fill the hose
Yeah.
and the other side will be exhausted, the valve switches, and we have the same procedure in the other way around.
Yeah.
So
Okay.
these are
So
the low-hanging fruits where we are looking first.
yeah, and I guess a good maintenance procedure as well.
Mm.
We'll be looking at those on a you know a regular period just to make sure that you don't have those leaks, and if so, then again, they're probably cost effective to get those treated and fixed right away. For example, in terms
That's right.
of efficiency, one of the things that we talk about when we're talking about operational efficiency is how do we actually get to that? Because I'm thinking maybe within a compressed air application, for example, if you're looking at efficiency, you may think that having more pressure in the system makes the system more efficient. Is that the case, or is there something else that you could maybe give us a little bit of background into
Mm.
system efficiency?
Normally, the designing of the machines from the machine builders are for pneumatic 6 bar as pressure.
Yeah.
This is not a directive, but it's in many cases it's a standard. Higher pressure at the machine definitely does not increase the performance of the machine. The cycle time will be the same because the cycle time comes directly from PLC.
Hmm.
What definitely increases with a higher pressure is the consumption because higher pressure means more volume flowing into the machine. And so we try to decrease the pressure if we see a machine running with 7 bar to 6.5 bar, maybe to 6 bar, if possible to 5.5 bar.
Hmm.
And see, okay, what is the performance? What is the speed of the machine? If the speed is the same with 5.5 bar, we leave the pressure at the input of the machine with 5.5 bar.
Great. So that's really interesting because in real terms, that doesn't sound like much of a reduction, but it could actually bring that whole system efficiency up to a different magnitude from pre-existing conditions. That's really
Yep.
good insight on that. That just leads me on to the next question in terms of Festo itself. So what is it in terms of supporting customers do you guys offer?
We have 2 lines. We can support the machine builders. We can also support, we call it the end users, so the production lines. And with our Festo energy saving services, we have a lot of solutions here for our customers. For example, our module called Audit for Compressed Air Systems. There, during this audit, the complete system is analyzed, as I mentioned at the beginning, the holistic view on the system.
Hmm.
And we do various measurements during this audit. The audit takes 1.5 to 2 days, depending on the size of the plant. And first of all, we are checking the data of the compressors. Running times are determined. The compressed air quality is measured during this audit in several points. First, directly at the central preparation, so in the compressor room, and then 2 or 3 times outside, somewhere in the production. Then we are measuring the pressure drop between the compressor room or rooms, depending how
Hmm.
much rooms they have, and the production equipment. Over 24 hours, we have a bunch of pressure sensors with data loggers, and they're time synchronized. And so we started, and every second we are recording the pressure in the compressor room and outside, and then we see how the pressure level is or the pressure drop between compressor room and the application, the production line. We are also doing a leakage detection, exemplary leakage detection, not for the whole plant, but for 1.5, 2 hours. And during this time, we are counting the leakages and also the amount of the flow rate. And then we can calculate how big the leakage level in the complete plant is, because we know how many leakages we can find during an hour or during a day. And then we can calculate this. And with all this data, then we are making a report. The report is standardized because all our services are certified by the TÜV Süd according to the ISO 11011. And so everywhere in the world where an auditor from us is working, the report looks definitely the same. Here in Germany, in GB, in Korea, somewhere else in the world where we have our auditors. So if we have customers working worldwide, they know, okay, if they're ordering an audit for the compressed air system by Festo, looks everywhere the same. And they have like a benchmark.
Okay. So earlier you mentioned fixed costs. So I'm just thinking back to obviously machine builders. So in terms of fixed costs, we're talking about the product they put into the machine build. So when they're selecting products, components, how much does like the sizing of components and component choice make a difference in that for energy efficiency? Particularly if machine builders are building new systems, for example.
For the machine builders, we have first our support, consultancy from our side, or our customers, machine builders can use all our dimensioning tools on our homepage. They are all free of charge for them, and then they can calculate. They need 5 or 6 data from the application, put it in the tool, and then they can see, okay, the tool mentioned I use a cylinder with a size 32 millimeters. Maybe I'm changing the runtime of the cylinder because the time, I have enough time to do this. And with a slower motion of the cylinder, I need maybe a cylinder one size smaller. And so we can play a bit with these dimensioning tools for efficiency, to have a higher efficiency on the machine.
Got you.
And the dimensioning tools are available for electrical drives. We also have electrical drives in our portfolio and for pneumatic drive, that's clear. And additional to these tools, we have also internal tools for more detailed calculation and comparison between the technologies. And so we can find the most efficient solution for our customers.
Yeah.
And it's clear, during the designing phase, this is the easiest way to implement these measures, because if the machine is outside at the production line, nobody touched the machine to change anything. Then the machine is running. They have to produce.
Yeah, absolutely right. So yeah, I was just going to mention that, the most important time for making the most of your machine and delivering energy efficiency is actually in that initial build phase. So it's quite important to understand that. And it's great to hear that you have that tools, service, and obviously support that machine builders can come to you guys with to ask for that support. Just want to recap on one of the other areas where we're talking about real savings in terms of costs, energy costs. At the moment, energy costs are rising more or less on a daily basis and only set to increase that way. So what we've covered today, you talked about where the energy savings could be made. So if we were looking at the low-hanging fruits, for example, a lot of the stuff you were talking about was within the fixed components, making sure and checking for air leaks. If then you are looking to build new machinery, go to Festo to try and find all the most relevant information before you move forward.
And we are happy to help our customers to build more efficient machine, to improve the efficiency in automation, not only in pneumatics, also for electrical drives.
Fantastic. Great. Roland, that's been a really great conversation. I really do thank you for your time today, and I hope we can talk again real soon.
Yeah, hope so.
So we've just been speaking to Roland Folk from Festo. I now have Christian from Festo. Christian, do you want to say hello and introduce yourself to Design Spark?
Yes, of course. So my name is Christian Oesterle. I'm responsible for the topic of sustainability at Festo overall worldwide. And this includes actually all the people topics we are driving, topics with regards to ethics and governance, environmental topics, but also measures we are taking to reduce our CO2 footprint. So my task actually is synchronizing and orchestrating all these activities going on within our organization.
Okay, that's really great. So I just want to maybe just delve a little bit further into what role does sustainability play within Festo as an organization? Obviously, you've alluded to that, but if you could maybe just explain a little bit more around how the company integrate and use that experience of sustainability.
Of course, yeah. So sustainability actually has an integral part of our corporate strategy. So as a responsible company, we have a clear focus on climate protection. However, for an organization to be sustainable, environmental, economic, and social aspects need to be considered. So in our understanding, sustainability is the prerequisite for long-term growth and economic success, I would say.
Yeah, that's really interesting to hear that, because we're hearing very similar things around sustainability being integral to an organization, particularly if that organization want to and still continue to be successful. So I just want to ask a little bit further in terms of outside of the products and the portfolio and service, what measures are you guys at Festo actually taking? Roland spoke about the products and efficiency and how we can get the best out of the products, where savings can be made and where more efficient operations can be seen. So I'm just wondering what measures outside of that Festo could enlighten us with.
Yeah, there is actually way more that we drive in order to operate a sustainable business, I would say. So first, we feel that we have a holistic responsibility for our products. Yeah. So, and this actually starts already in product development, when our focus is on material efficiency, but also on saving resources, for instance, through applying lightweight design, for example. If we, however, also look on our own infrastructure, we are also investing heavily in our own renewable power generation. And in parallel, we are also working on energy saving measures in our old buildings and in our plants. And as an example, as a result, from this year, from 2023, we will be CO2 neutral in our buildings in Germany and in our global production and logistics sites with regard to scope 1 and 2. If we look at our supply chain on the other side, we are, of course, further developing a local for local approach. So this helps us both to save resources in our logistics activities on one side, and on the other side, it also improves our resilience, obviously. If we look at the social dimension of sustainability, the topic of lifelong learning is actually an essential part of our corporate culture. And this means we continuously qualify our employees for future requirements. And last but not least, Festo Didactic, on the other side, plays a very important role and is having a big contribution to the technical qualifications of future generations with its holistic educational offerings. So as a summary, you can see that we are working on all three aspects. So we're working on environmental topics, economic, and on the social aspects of sustainability.
Yeah, what I was really interested to hear there was certain things that you were talking about, the economics behind social responsibility, and actual fact that the economics is actually improving due to social responsibility, but then also in terms of yourself as a company investing in the education of future engineers to think and design for more social responsibility. That to me is really great to hear. And I'm just interested within the company itself in terms of the employees. Obviously, you're talking about giving employees more access and awareness of their social responsibility and what they do within work. How receptive are the employees to that? Because I know within our own organization, it's some of the things that we actually preach on a daily basis.
So to be very honest, we are the employees at Festo are very open to all the topics that we are driving here at the moment, and we see a very strong pull also coming from the employees at Festo asking for those topics and asking for all of those measures that we're currently taking. So, and this means we actually see that we are on the right track of actually meeting all those future requirements in terms of sustainability.
Great. That's really good to hear. And I really do thank you for giving me your time today, just to give us a little bit of an insight into what sustainability means to your organization, to you yourself, and obviously thank Roland for talking to us about the product side. So I would love to have you guys back on Design Spark sometime soon, and I just really thank you for your time today.
Thank you very much, Craig, and I hope you have a great weekend. Talk to you soon.